Hey, A-level physicists, what's the crack? So today we're starting capacitors, okay? So this question says, I've got a capacitor and I'm going to put a dielectric in it, a dielectric constant of 5.0, okay? I put it between the plates and it wants me to describe how the capacitance changes with the polar molecules, okay? So just a reminder, what a polar molecule is a molecule where it's got slightly positive on one end and slightly negative on the other end. So an example of that could be water. Okay, so if you don't need to know this for physics, but just for example, if you do chemistry, you know oxygen is more slightly negative where hydrogen is more slightly positive. So polar molecules is when the electrons get pulled to one side more than the other. So where the electrons get pulled to is negative and the other side becomes slightly positive. Okay, so if I've got my capacitor to here and let's say I connect to my cell, there's the longer side is my positive, the shorter side is my negative. So I know this side of the capacitor is going to be my positive plate and this side of my capacitor is going to be the negative plate. Okay, so when I put these polar molecules in between my capacitor, they are going to line up to match up with the charges in the plates. Okay, so if I put this polar molecule in here, they're going to line up so the slightly negative is attracted towards the positive side and the slightly positive is attracted to the negative side. So all of my polar molecules are going to line up in that direction. So I know an electric field shows me the direction that a positive test charge will move. So the electric field between these two plates is in this direction, away from a positive test charge move to the negative. But the polar molecules have set up an electric field to oppose that in the opposite direction. So we can clearly see here that the two vectors are going in opposite directions. So the electric field between the two plates has been decreased. Okay? And I know E equals V over D. So if I've decreased the electric field between the two plates, but the distance between the two plates has stayed the same, that must mean I've decreased the potential difference between the two plates, okay? So if I've decreased the potential difference between the two plates, I know the equation for capacitance, C, is Q over V. So if I've decreased the potential difference, I've made this number lower for a given charge, because the charge will be due to whatever cell I've used. So for a given charge, if I've decreased the potential difference, that must mean the capacitance has actually got increased, okay? So my free marks here is for one, saying that the polar molecules line up with the charges on the plates. So my positive end of my polar molecule lines up with the negative side of the plate. Then I know that the electric field between the plates is decreased. I know that the potential difference is decreased between the plates. So then overall, what's happening is that my capacitance has increased. Okay, and that's my free marks there, so that's grand. Follow me for more physics content like this.